Okay, so let's go ahead and do a quick recap of what we've learned about the sampling distribution. Okay. First off, the sampling distribution is the probability distribution of all possible values of a statistic for a given sample size taken from a population. Okay. Now, specifically, we talked about the sampling distribution of the mean. Okay. So, suppose that we have a, a population with a variable x, right, with the mean of mu x and the standard deviation of sigma x. And then we decide to take samples of size n. Right? Now, if we could, one, take all possible samples of size n, right? Then calculate the sample mean for each of those samples. And three, construct the distribution of those sample means. Okay. Then we obtain the sampling distribution of the sample mean. Okay. Now the sampling distribution of the sample mean is characterized by three things, right? First off, the expected value of all the sample means, which is the mean of all the sample means, is equal to the mean of the underlying variable. Okay. Second, the standard deviation of all the sample means is equal to the population standard deviation divided by the square root of the sample size. Okay. Now remember that sigma x bar is just the standard deviation of all sample means, okay, which is also referred to as the standard error of the mean. Okay. Third, we want to talk about the distribution shape. Okay. So to determine the distribution shape, we follow the following procedure. We use the following procedure, right? First off, we ask ourselves, is X normal? Okay, so is the underlying variable normally distributed? If the answer to this question is yes, then X bar will be normal regardless of the sample size. Okay. Now, if the answer to that question is no or unknown, right, then we look at the sample size. Okay. If the sample size is greater than or equal to 30, then X bar is normal. If the sample size is less than 30, then we don't know how X bar is distributed. Okay? Now it is very important. It is very important to distinguish between the two random variables X and X bar. Right. For example, suppose X is normal with mean mu X and standard deviation sigma X. Okay. Then we know that X bar is also normal with mean mu X bar equals mu of X and sigma X bar equals sigma X divided by root n. Right? Note that these are two different distributions. Okay? They have the same mean, but different standard deviations. Okay? So, to find probability, we need to correctly identify variable of interest, right? Okay. In other words, if you are asked about x, then you want to use mu of x and sigma of x to standardize and find probability, right? But if you are being asked about x bar, then you want to use mu of x bar and sigma of x bar to standardize and find probability. Okay,